start module 3, that is based on transport protocols. So as you know that the transport layer which works, which is the upper layer, which acts as an upper layer to the network layer that we studied in the previous module. Okay. So this layer, basically the transport layer. So we have two transport protocols here to discuss. One is for connection oriented, that is called as a transmission control protocol, or it is referred to as TCP. While as you know that it is a connection oriented protocol and it is a reliable, it provides a reliable communication, and it basically deals with the end-to-end delivery of the data. Okay, and as I told you earlier that since it deals with an end-to-end delivery, it also provides flow and error control, congestion control, right? It makes sure that the data is delivered in a sequence, okay, in a sequential manner. And as you know that since it is connection oriented, so obviously it is reliable, right? But as you know that all applications may not require this, may not be suitable to go for this connection oriented thing, because it requires a large overhead in establishing a connection. Okay, because a logical connection has to be established between the two TCP end users, and the data will be transferred from one user to the another user based on the socket address, right? I told you earlier that what is the socket address? Basically on a machine or on your computer, you must be running multiple processes at the same time, like Gmail, Facebook, Microsoft Teams, and each process will be identified by a port number. So once you club both the IP address and the port number together, okay, to identify a process, right, that is called as a socket address. So this, as you know that the IP is responsible for delivery between the two end users, right? So each end user is identified by an IP address, and on that end user, where the multiple processes are running, each process is identified by a port number. So some of the processes are having some well-known port addresses. Some of the port numbers are assigned dynamically, right? So all those things we will see that how the port number is being assigned, okay, and what are the well-known port addresses. So the process is identified by a port number, right? So as I said that there is a connection establishment problem, connection establishment and its termination. Okay, when both the party agrees to terminate a connection, they can terminate it, right? No more connection is required for data transfer. Once the data transfer is over, the connection can be terminated. So I told you that termination can have two ways. One can be a gradual termination where the data in the transit will not be lost until unless all the data in the transit is delivered. The connection will not break. Okay, no party will terminate the connection. Another way can be an abrupt termination of the connection, where the moment the party decided that it doesn't want to be in connection with the other party, it can terminate it immediately. So the problem with that is that the data which is in transit, which is in the network, gets lost, right? So as far as the connection oriented thing is concerned, you can see the diagram, you can see the arrows. Okay, it works at the layer 4, so it is an end-to-end. So I have already mentioned you the meaning of an end-to-end. This is what we are going to study, right, in the third module. So it is an end-to-end process, end-to-end delivery of the data. So once I am saying end-to-end, you understood that it is being performed based on a port number, right? IP address plus port number. as connection oriented. So connection oriented means a connection has to be set up. This connection can be a two-way handshake, but there are many issues, right? So suppose basically when the two parties wants to open a connection, suppose one party send a hi message to the other party, right? The other party needs to reply back with the same hi so that the connection can get established, right? So this is called as a two-way handshake. Okay, but there are some disadvantages, right? Like you do not know because suppose you send a hi message to someone, some of your friend, right? If the addresses are not known, like if the names are not said, you send a hi, but he didn't respond to you during that period of time, or his response got delayed in the network, right, and appears at a later stage of time. So that creates issues in the like management. So like duplication and other things. So duplicate detection and other things are very important, and the sequence number also. So two-way handshake has some limitations, right? And we will see. So basically, we use a three-way handshaking to avoid those issues which results due to the appearance of an obsolete segment from either from the previously closed connection or a delayed one, right, which got delayed in the network. So there is a three-way handshake, two-way handshake. So we have flow control, error control, congestion control, right? So here flow control we use credit-based scheme. Just you remember that you had gone through like the stop and wait, sliding window protocol, right, for flow control mechanism. So here we have a credit-based scheme because those schemes were having disadvantages associated with them. Because here the main advantage of a credit-based scheme is like you have a credit card, bank has given you some limit to spend, okay, and it is up to you, right, that how do you want to use it. Suppose if you have a credit limit of 10,000 rupees, right, so you can use those 10,000 at a time. Okay, you can buy a product of 10,000 rupees, or you can use it two times. So this 10,000 credit is given. So credit means the receiver assigns the credit to the sender. Sender can send that much segments at a time, okay, that much octet of data at a time without waiting for any acknowledgement, right? So the beauty of this algorithm is that the credit-based scheme is that all the received segments are acknowledged without assigning the future credit. Are you following? Like in a stop and wait, kya hota tha? Can you say what was there in stop and wait? Anyone? What was there in a stop and wait? The moment you receive an acknowledgement, then the sender immediately sends one more packet, right? One more frame. The sender is allowed to send one more frame once it receives the acknowledgement, right? So the receiver sometimes uses the conservative strategy to hold the acknowledgement, because it knows that if it acknowledges the segments, if it acknowledges the frames, the sender is free to send more segments, right? And it cannot handle it. So you know that there was a piggybacking that so multiple segments, multiple frames can be acknowledged together, right? So this was an approach by the receiver to protect itself from an excessive flow from the sender. So you must note it that in a stop and wait, the sender is allowed to send more frames once it receives the acknowledgement. Similarly, in a sliding window protocol also, the window gets advanced or shrink based on the number of acknowledgements, right? So here, so the issue with those algorithms were that if a receiver is not in a position to receive further frames or segments, it cannot restrict the sender to not to send it, right? But in this algorithm, in a credit-based scheme algorithm, the sender, the receiver cannot assign any further credit and acknowledge all the received segments so far in the received by the receiver so far, right? So you can acknowledge all the previously received segments without assigning future credit to the sender. So that is the beauty of this credit-based scheme. So there are different timers which are used in this, for this three-way handshaking, and like in TCP, the TCP is mostly work on a large number of timers, right? We will see that what are the different timers it uses, right? So there are different timers, persistence timers, retransmit timer, okay? And what exactly, I can give you a reference like what is a retransmission timer, that what is the RTT value. So there are error control, right? Error control is being addressed by using these timers, right? If any error is there, so how this error will be managed, okay? Flow and error control, and then congestion control, right? Congestion control has got two components. One is a window management, like the window is what? The assigned credit to the sender, right? If you restrict the amount of window size, if you restrict the window size, the sender is not allowed to send much data on the network, and hence the network will remain congestion free. But at the same time, there is another factor that deal with the congestion control is, one is a window management. So we have different schemes for that. Another is a timer management that creates congestion. How? Like, so there are two aspects of congestion control. One is a timer management, another is a window management. So in a window management, the size of the window is changed or adjusted based on the network conditions, right? So that it should not be very aggressive and it should not be very sluggish also, right? So there are different schemes like a slow start and a dynamic sizing on the window, right? So that makes it in a way that the network should remain congestion free. But the other component that also deals with the congestion is the timer management, like the retransmission timer, right? Like if not a retransmitter timer, like what should be the can you say what is retransmission timer? Anybody? What is the meaning of a
So
retransmission
when
timer?
the acknowledgement is not received, so time after the timeout, then the packet retransmitted by the sender.
Right. So if a acknowledgement is not received in a given time, right? Then it has to retransmit it, right? So who will decide that what should be the time that a sender should wait for an acknowledgement? Can you say, how will you select a time for uh, for the sender to decide what should be the retransmission value, retransmission timer value? Can you say? It is like just when we are going to city, suppose we are going to Ranchi from Masra campus, and suppose and I expect that I will come back within a given time. Okay, but if I could not reach here because of there is a congestion in the on the road, I may not reach it in time, right? So if I'm not reaching in time, like similarly, if a acknowledgement is not coming in time, the sender will get timed out. It will retransmit it. So if already the network was congested, right? There can be two possibilities. Either the acknowledgement has got delayed because of the congestion in the network, or the acknowledgement has been delayed by the receiver as a conservative policy. The third thing is that the acknowledgement is lost, right? So in all the three circumstances, if the sender times out, will retransmit, right? So if the sender retransmit it, so already the network was congested, and suppose if many such senders are there, right? And then it will further, congestion will get improved, right? It will further congest the network. So how to deal with this situation? So this is a very important like aspect to deal with the congestion control, right? So basically, how to select a retransmission timer value, or how to select a RTT value. So if you select a static value, some static value, right? So you said that 100 nanoseconds, that you are expecting that you will be transmitting the segment from sender side to the receiver side, and you are expecting that an acknowledgement will come back during that period of time. So if this static value, the network is not congested, if you choose a large value of it, right? You choose a large value of it, what will happen? Your capacity will get wasted, and the protocol has no meaning. But unfortunately, if you take a very small value of it, suppose if you choose a 10 microseconds instead of 100 microseconds, you choose 10 microseconds, and then you see that during that period of time, if you are not getting it, there will be more such retransmissions, and further congestion will get, network will get more congested, right? So it is to be chosen very widely. There are some algorithms. How do we do it? So we will discuss all those things. It's a very interesting part that this module is very, very interesting if you are interested like in this side of computer networking. Okay, and there are many questions in the placement side. Okay. So I'm just starting. Okay, this is an overview what we are going to see. So as you know that what are transport protocols? So they are responsible for end-to-end data transfer service. Okay, so they basically shield upper layer from network details. So upper layer of transport is application layer, right? So different applications which wants to take the services of the transport layer, they pass their data to the transport layer, and in order to route that data between the two end users, transport layer accept the services of the network layer. And network layer, in order to route the data between two devices, right? It takes the services of the LLC, and then further MAC, like to govern access, like to control the access over the data transfer, right? So it is reliable. As you know, it is connection oriented, reliable. It checks reliability. Reliability means that it provides flow, error control, congestion control. It deals with the sequencing of data. So as I told you that each layer has its own conventions, right? So if I say about a data link layer, there was a you remember there used to be a frame. Okay, we call it as a frame. Okay, in the physical layer it is a raw transmission of bits. In the link layer we call it as a frame. Okay, and then in the network layer we call it as a datagram, and in the transport layer we call it as a segment, right? Similarly, if I say about the connections, like the addresses, so in the MAC layer, in the link layer, we call it as a MAC address, right? And then network layer, we have an IP address. In the transport layer, we have a socket address, right? So So it has connection oriented. So as it is connection oriented, so it is more complex, right? Because creating a connection over this wide network it will involve many has many complexities involved, right? Then and the example of such a protocol is TCP, transmission control protocol. So it's a connection oriented protocol. There is another protocol at the transport layer which is connectionless. Okay, so that is basically UDP, user datagram protocol. Okay, this is basically used in situations where we can our data is not very much like where we can compromise, right, to some extent with the data, right? We are not very much particular about the delivery, sequencing, and everything about the data. So here, if some of the things, like some of the segments, though we missed it, okay, will not make any difference, right? So applications which can adjust with such characteristics can use this UDP because it is connectionless. So overhead of connection establishment is not there, right? So this also accepts out the services of IP, right? Because UDP data is also encapsulated in the IP datagram, right? So for routing purpose, so it is basically it provides a kind of a best effort service what the IP provides, right? So this is good for applications where we do not want to have an overhead of connection establishment. So we can go for this UDP. So it has got many applications, right? Even your messages which you receive when you make any transition in the bank or anywhere, those are all UDP based messages, right? Every time you get a message, that is all UDP based. So sometimes it is very if you see that the ratio that it is very less chances that you are getting the data, you are not getting the not receiving the SMSs, but mostly you are getting the data, right? UDP messages. So you know we are talking about, we will first talk about the TCP, right? Then we will see that what are the complexities involved in the protocol, connection establishment protocol. Then we will slowly move on to the connectionless protocol UDP, right? So if I talk about connection oriented transport protocol, it provides establishment, maintenance, and termination of a logical connection. So just like you already studied it earlier, and we also had a little discussion on LLC, logical link control, right? So you have already studied about SDLC, submit. So SDLC protocol. So here this connection oriented, so a connection is to be established, so a logical path is to be established between the sender and the receiver, and it is to be maintained till the completion of the data transfer, right? And once the data transfer is over, a connection is to be terminated. So it is the most common service. It is used for a wide variety of applications because it is reliable, but it is complex, right? So you will see what are the complexities involved. So let us discuss from reliable to unreliable network service. So the networks are also classified in different classes like reliable network. There are class A, class B, class C, class D networks. So here we have a reliable sequencing network service. So here we assume that since it is reliable, right, we will not lose any data, right? No packet, no segment will be dropped, right? So we assume 100% reliable delivery by network service of arbitrary length messages. Okay, so some examples are given here. That is reliable packet switch network with X.25 is a packet switch network. Okay, and frame relay, LAPF control protocol. Like I told you about the 802.3 Ethernet with connection oriented LLC service, so which basically uses the submay mode of SDLC protocol, right? So this transport service is simple end-to-end protocol between two systems on the same network. But what are the issues? The issues are like addressing, multiplexing, flow control, connection establishment, and termination. Right? So we will be dealing with all those things. So as I told you about addressing part. So it is basically a combination of the network address or the IP address plus port number. Right? So that is called as a socket. Host is identified by a IP address plus port number. Process is identified by a port number. So it is a global internet address because of a host, and it's a network number. The transport layer passes host to network layer. Okay. So you know so there are different things like how will you know about a port number, right? So suppose if you are involved in any, like if a host is involved in any communication with the other host, how will it know about what port number this application is running, right? So there are few mechanisms that like how the port addresses are assigned. So you can know address ahead of time. Okay, you can directly ask the process, or to know the address ahead of time, that what address is on this, that port number is there on which this process is running. Some of the addresses are well known, like they are well defined services like FTP, SMTP. So for them the port numbers are fixed, right? Otherwise there is a provision of name server. Okay, the host requests the name server to provide the port number. So name server provides, look up the directory and provide the port number of the process, right? So these are the different ways on by which we can finding out the port number, right? I will tell you about there are how many port numbers are possible. Around 2 to the power 32 it is there. So how they are defined in different categories. Okay, I'll come to that later. Multiplexing. As you know that multiple logical connections can be multiplexed together. Okay, to be upper layers, like there is a, you know, the downward multiplexing and upward multiplexing that we studied earlier. So multiple users employ same transport protocols. The user identified by the port number or the service access point, right? Service access point we say in a OSI model, right? So they are identified by the service access point or the port number. The upper layer users. So downward multiplexing is performed, right? And so upward multiplexing is also there, like multiplexing a single virtual circuit to a number of transport service users. So when the data is coming from the lower layers to the transport layer, it is called as a upward multiplexing. So here the data which is coming to be delivered on multiple transport users, so that is called as the upward multiplexing. And in the other way, if you think that the upper layer data multiple users wants to use the same transport protocol, so all of them will be multiplexed together and will be sent, and each process will be identified, each application will be identified by a port number, right? So flow control. So as you know that I just introduced to you about the credit scheme, right? Just told you about the credit scheme, that what are the issues in flow control, right? So if we are using, like, you can know that the longer transmission delay between basically, what are the issues? The main issue is the variable transmission delay. You never know the network conditions, when the network conditions will change, right? So you are not very much sure about the network conditions, and that results in variable transmission delays in the network. And because of that, the longer transmission delay between the transport entities, okay, compared to the actual transmission time delays in communicating this flow control information. So that is what the main issue, right? So and why a transport service want a flow control? Because the receiving user cannot keep up. So there are two things. There is a There are two things I told you. The upper layer. Upper layer is called, suppose some application. So it will be called as a transport user. Okay. So on this user, this transport user may be using, this transport user is not ready to accept the flow is so excessive that this transport user is not able to cope up with the flow, right? Or there is another thing that the transport entity like the TCP, okay, is unable to cope up with the flow. There are two things: either the user or the protocol itself is not able to keep up with the flow. So that will result in buffer overflowing and subsequently dropping off segments. So it is very difficult. So what could be the scope? So what could be done in such scenarios? To do nothing. जो हो रहा है होने दो, right? If the segments are getting dropped, let them get dropped. No matter, do nothing. So that the segments that overflow are discarded. Okay. So sender will not get any acknowledgement and will retransmit. Right? Can you say, will this scheme be useful? Can you say, will this scheme be useful? See, first of all, when we are talking about reliability, right? When we are talking about reliability, okay, when I'm saying that a transport protocol TCP, which is a reliable one, and so reliability cannot be judged based on this do nothing, right? You cannot, if you are talking about reliability, you cannot leave the segments to be discarded, right? And once they get discarded, the sender will retransmit them, right? That will further congest the network. The situation is going to be worse. So doing nothing is not a good decision as far as the reliability is concerned, right? So this is not acceptable. So refuse further segments. What do you mean by the refuse further segments? That if the receiver is not able to handle it, right, it will refuse, like sending a choke packet back towards the source, right? But if the network is congested, that may also fail to reach. So refusing further segments means what? Conveying the information towards the source that I cannot deal with this flow, kindly slow down, right? So it basically triggers network flow control, but clumsy, because you may not get the instant results, right? use fixed sliding window protocol. Do you remember the sliding window protocol? Can you say? Anyone?
Sir, there was a fixed window and frames were transmitted according to that, and then the frames that were transmitted, they did not wait for the acknowledgement, and when they get that acknowledgement, then the window slides over.
Right. So the sender is allowed to exhaust its complete window size, whatever is allotted to the sender by the receiver. Right. The sender can send that many segments at a time without waiting for the acknowledgement. Right. And once the acknowledgement receives, suppose it has if a window size is of 7, and if it has exhausted all the 7 segments, it has transmitted all the 7 segments, and it receives an acknowledgement of 4 segments, right? So it is allowed to send 4 more segments, right? So the sliding window works like that. But you think of it, suppose the sender has transmitted the 7 segments. If the window size is 7, let us say, sender has transmitted all the 7 segments. Okay? But the receiver has not acknowledged anything. Okay? Or receiver has acknowledged this is an act. Okay? So this is an act, but this eventually didn't reach the source. Let us say. Then what will happen? And the source will get timed out. If this acknowledgement doesn't reach at the source will get timed out and it will retransmit all the segments again. Right? Assuming that the segments are lost. So as far as we are concerned about a reliable network, right? If the acknowledgement is not received by the source, there can be 2 things, right? That either it is holded by the receiver, right? Because the receiver is not able, receiver buffer is overflowing, so receiver has holded the acknowledgement, right? It is a tactic of the receiver to hold the acknowledgement so that once it creates a space, buffer space, it will release an acknowledgement, right? It can be a tactic of the receiver. Secondly, the receiver has given an acknowledgement, but it is delayed or lost. It failed to reach at the source before the source gets timed out. So if it is so, right? So what the source will assume, since it is a reliable network, okay, the chances of losing frames, the possibility of losing frames is not there, right? It is impossible to lose the frames because it is a reliable network, we assume. So sender will assume that this acknowledgement has been holded by the receiver or it got delayed, right? So there is no issue with the reliable network. This sliding window protocol works well with this reliable network. But when you talk about unreliable network, right, where there is no assurance that the frames will not get lost, right? There is no such assurance in the unreliable network. And if this acknowledgement get lost in the network before the fail to reach at the source before it gets timed out, it has to retransmit all, right? So even though it has to retransmit all the segments, so further it will create a congestion in the network. Then secondly, even though they were received successfully, all these segments were received successfully at the destination, there will be a duplication of them, right? In an unreliable network, there will be a duplication of the same frames again, right? And an acknowledgement, if it gets delayed, there will be multiple acknowledgement received by the source of the same frames, right? So there are many issues in an unreliable network. So as long as reliable network is concerned, the sliding window protocol is fine, right? Another main difficulty with the sliding window protocol is that the moment the sender receives the acknowledgement, it is entitled to send as many frames depending on the acknowledgement received, right? So it immediately send the frames. But suppose if the receiver is not in a position to handle more frames from the sender side, and at the same time it wants to acknowledge all the previously received segments, right? So that the sender should not get timed out, should not retransmit all the frames again. So how to deal with this situation? So for that, there is a scheme that is known as the credit scheme. That is a flaw in the sliding window protocol or stop and wait protocol, that the receiver cannot acknowledge the received frames till uh, without allowing the sender to send the new frames, right? So there is a credit scheme. What is the credit scheme? So it decouples flow control from acknowledgement. Generally, whether it is stop and wait or sliding window protocol, the acknowledgement basically controls the flow, right? Acknowledgement is being used for flow control. So it decouples flow control from the acknowledgement. So each octet has got a sequence number, right? So each transport segment has got a sequence number, acknowledgement number, and window size. So there are three parameters. So acknowledgement includes, right? The sequence number of first octet in segment is to be sent. I have one example, right? So acknowledgement includes acknowledgement number and the window size. Window size means the credit assigned by the receiver to the sender, which means, and this acknowledgement means, if this is I, right, this acknowledgement means that all the octets through serial number I minus 1 are acknowledged, right? So that means the receiver is demanding the new octet starting from this I. So all the previously received octets are acknowledged, right? And this is what the credit assigned by the credit remaining for the sender. How many credit the sender can send now, right? So let us see one example. There are two transport entity wants to exchange data, right? So here, how do we work? We assign a sequence number, right? This is what a sequence number. So a size of a segment is decided by the TCP, okay, by the transport layer, that one segment may hold how many octets of data, right? I will explain you why, because there are two things in TCP that TCP has its own discretion to decide the size of a segment, right? So when the size of a segment is defined, so how do we give a sequence number? Suppose each segment is of 200 octets, you can see. Each segment is of 200 octets. The segment size is of 200 octets. To the sender, it is allowed, okay, so A is allowed to send 1400 octets, right? So its sequence number will vary from 1001 to 24000, So it starts sending 200 octets, 400 octets. So it sends, and each segment has got a sequence number. How the sequence number is given? From the first number of the octet, right? 1001, 1201, 1401, and each segment has got 200 octets of data. So once it sends these three segments, right, you can see that the B sends an acknowledgement. Acknowledgement is 1601, right? So you can see that AN equal to I means what? It has received 1001, 1201, 1401. What is the next segment the receiver is expecting? What is the next sequence number of the segment that the receiver is expecting? That is 1601, right? So by demanding this 1601, it means that it has already acknowledged all the previously received segments, right? All the segments with sequence number I-1 are acknowledged. Now you see that it has transmitted, the A has sent how much octets A has sent? 600 octets A has sent, right? How many octets were left? 800 octets were left. But at any instant of time when the receiver feels that I have more capacity, I have more buffer space to accommodate 200 more octets. Please listen carefully. This is very, very important to understand the working. That receiver assigns a credit to the sender. So initially, B has assigned a credit of 1400 octets. Just assume a situation like a hotel room, right? You visit any hotel website, right? How do they allocate rooms? There can be two policies there, right? One can be a conservative policy that मेरे पास जितना खाली है मैं उतना ही दूंगा, ठीक है? अभी हम लोग कंजर्वेटिव पॉलिसी के बारे में ही बात कर रहे हैं, ठीक है? कि आज इतने गेस्ट आए हैं, मेरे पास 50 रूम है, आज अगर 40 गेस्ट आ गए, 10 रूम खाली है, आई कैन गिव ओनली एश्योरिटी फॉर 10 रूम, ठीक है? और हो सकता है कि 2 रूम और खाली हो गए, ठीक है, या 2 गेस्ट टर्न अप नहीं हुए, या 2 गेस्ट जल्दी चले गए, तो आई फील दैट 2 more rooms are vacated. So at any instant of time, the receiver can assign more credits. Whenever the receiver feels that it has more space to accommodate, more buffer size to accommodate, more octets, it can increase. So here also, initially assigned 1400 octets, 600 A has transmitted to B, and once B receives 600 octets, it feels that it can accommodate 1000 more octets. In place of 800, it can accommodate 1000 more. So it has advanced the window, it has increased the credit to 1000, right? At the same time, it demands a new segment starting from 1601, acknowledging all the previously received segments, right? So now the sender will send 1601, 1801, like that. Cumulative acknowledgement is there, just like you remember in previous thing, that flow control exercises, and the cumulative acknowledgement. So acknowledgement 2601 means it is acknowledging all the previously received segment and demands a new segment starting from the sequence number 2601, and it has given a credit of window 1400. Okay, so as you can see that A shrinks its transmit window with each transmission. So its window size is shrinking because it is getting less credit for transmission. So credit limit is shrinking, right? And B acknowledges 3 segments but is only prepared to receive 200 additional octets beyond the original budget. So like that, whenever the receiver feels, so this is what a kind of a credit scheme allocation. So the beauty is, like, at this moment, right, if it feels B feels that it doesn't want any more transmission from A, so what it has done, it has acknowledged all the previously received segments with a window size made to 0. So that means it doesn't want any more data from A. At the same time, it has acknowledged all the previously segments. So this is what this scheme is very, very good, whether you are working in a reliable environment or an unreliable environment, right? To exercise flow control, this scheme, first of all, it decouples acknowledgement from the flow control, because this credit allocation, right, dictates whether how much data a sender can send. I hope it is clear. But this scheme is also a bit conservative, right? हम लोग देखेंगे आगे जाके. But I can give you a hint that, like in a hotel room, so there can be two types of managers. One is a conservative, जितना खाली है उतना ही room I will offer to the guest for booking. But another is like a dynamic one, right? He will feel that, okay, there is a possibility that some of the guests may not turn up, some of the guests may leave early, right? So looking for the positive side, that maybe I am able to clean up this much space, right? The receiver grants more credit to the sender, that by the time the sender will send this much data, right, this much space is going to be cleaned. So that is what a kind of a dynamic thing, right? Dynamic credit allocation. So you will see in detail, it is quite interesting, right? Since the time is over, so you will see it tomorrow. Okay, thank you. For any doubt, please feel free to ask. Huh? Thank you.
Thank you, sir.